best, like no one ever was.
Today we're going back to classes and objects and discussing some more complex variants that I didn't mention before. There's a lot more code in this video, so I might jump ahead in my coding, but I'll explicitly call out points to pause the video so you can copy what I have on screen. So, create a new project, advanced classes, a new class, advanced classes test, and give it a main method. Pause here until you're done. So far, you have seen regular classes and good old-fashioned inheritance. You have a thing, that thing has children and grandchildren, and it can be used and stored in other things. This is a pretty straightforward way to live life. But programming is all about dark secrets and ancient rituals. It's also about being explicit when you're doing things that meet a technically different definition. Now, we're going to go over all of those rituals. Firstly, we will discuss the forbidden spell known as Inner Classes. Now you might be asking, what makes it forbidden? New to dark magic, aren't you? Inner classes are exactly what they sound like, a class declared inside of another class. These are used infrequently, but there are certain patterns that emerge when you might want to use them. And pretty much anytime you use an inner class, you could also just write it as a separate class. It's really a matter of personal preference. But inner classes can do special things like access private variables of the outer class, which a separate class would not be able to. The most common one is something called a Bob the Builder, or just Builder for short. We will use this as our example to show the great power of an internal class. Effectively, objects might not always have custom values for every class variable, and you don't want to create a new constructor for every single possible combination of variables. What you can do is create a new class that helps you build your other class. Its sole responsibility is to allow users to string together the variables that they want to use in a nice, readable fashion. Then you build the object at the end. Just as a note, you might want the inner class to be private if you're only using it as a helper for the outer class, but builders are usually public, so we're going to leave ours that way. Let's code it up to really see it in action. First, create a class called Pokemon, similar to the one from the intro series. Give it a name, level, and type. And two constructors, a default one and one with all the values as parameters. Pause here until you're done. Now, add our methods, say name, level up, and evolve, which for now will return a Pokemon object, and just use return new Pokemon just to get things going. Pause here. Next, we'll create a public inner class called Builder, which will have copies of the variables of the outer class and an empty constructor that gives default values to everything. Then add a setter for each of our variables above. However, now the setters will be just the variable name, no extra set word. They will also return the builder, which allows us to string it together. Lastly, create a build method which will return the Pokemon object we are building by using the constructor in the outer class. Pause here while you catch up, since I know I went through that pretty fast. Now, before we go back and test this, there's one little aside I forgot earlier. We need to make this inner class static, because we're going to call it the static way, where we would do Pokemon.builder. Now, back in our test class, let's instantiate our builder. Pokemon.builder equals new Pokemon.builder. And now we're going to set our variables and create our new Pokemon. So let's do Pokemon Wartortle equals builder.level16. Then without using a semicolon, just go to the next line and do .name Wartortle, next line .type water, next line .build semicolon. Now call the same name and run it, and you should see it say Wartortle. And another interesting thing to note is you don't need to do the builder in a separate line. You could have just done Pokemon Wartortle equals new Pokemon.builder, and then immediately went into .level, .name, .type, etc. That's actually more commonly used in the real world. I just wanted to split it up so it was a little bit easier to understand. Secondly, we look into the ancient ritual of enumerations, i.e. enums. These are an even more formal way to write constants. Because of this, there are a lot more rules that you need to follow, which is standard fare for ancient rituals. Enums are special classes that are written as a comma-separated list of constant variables. They come with a default value, which is a string representation of the enum's name. And since we usually write enums in all caps, they will also be all caps. So, let's code it out by creating our types, And we'll do just a few for now since there's 18 of them. Create a new public enum called types, and then in all caps, fire, comma, new line, water, grass, electric, normal. And then add a semicolon right at the end. That's it. Now I can reference these in a class anywhere, just like a utility constant. Loop through them by calling types.values, etc. So let's go back to our main method, go down to our type, and change it from a string water to types.water. And then we're going to do a dot name here as well because we're using strings as our variable. We could set it as an enum value, but we'd have to change our variable to be the enum instead of just a string. So we'll leave that for now, but you probably should do that in the real world. Before we continue, we need to go back to Pokemon and allow us to actually get the types that we can print it. So let's go back to Pokemon, add public string get type, return this dot type. And then when we go back, system.out.println or turtle.getType. And if we were to try to print out our type, we would see that it is water in all caps. But what if I want to give these custom values, like a non-caps locked version? This is also supported, but requires a little bit more work. Let's give our types a value by adding in parentheses on the fire, we'll add fire, water, water, etc. That defines what the new value would be, but we're not done just yet. We need to declare the type as a private variable, give it a constructor, and a get method to return it. So let's call this private string label, and then the constructor types takes in string label, this dot label equals label, and public string get label, return this dot label. Now go back to our test class, and we're going to update our builder to use this new enums label. So types.water.label. Run it, and it works just like before, but now you have a special utility class also defining our type that you explicitly know how it works. And all Pokemon can share the same type representation, so a Squirtle and a Totodile are both the same type of water type. Now, there are a few small things I want to make note of. Your enum does not have to be all caps, they just usually are. .name will turn whatever you typed into a string, so since water is all caps, it returns all caps water. And we can have any value we want in those parentheses, from a string to an int, or even a list of different types of values. These will be comma separated in the parentheses, just make sure they match up whatever order you have in your constructor so that they can pair, and make sure you have an included variable and getter for all of them. Going forward, I plan to provide starter code to help prevent this issue of too much code for one video from happening again. I've run out of time here, but there is a part 2 coming out soon, so for now... Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.